heat or air current. And in volatility, we have two methods, vaporization method and distillation method. So vaporization method, as we know, we supply some heat and the volatile substance or the maximum, the higher is the volatility of the component, more easily it will vaporize to the atmosphere. So this depends upon the volatility of the component. And second one will be the distillation process. So in distillation, as we know, the pure component is separated using the method of evaporation or by supplying heat. So distillation, we will also discuss the distillation part in separate part in today's session. So just you just remember, distillation is primarily of 5 types under volatility. So it is fractional distillation, flash distillation, vacuum distillation, steam distillation, and azeotropic distillation. We will discuss one by one in the latter part of today's session. Then second one is your solubility. As we know, solubility depends on the solvent and the solute we have. We take to form the solution. That means the solute is dissolved in the solvent depends on its solubility. So whenever the solubility means the separation, if essentially implies precipitation, the constituent of interest from the solution. When the solubility limit of the solute is exceeds solute in the solvent exceeds, the material appears as a precipitate. That means in a solution where the concentration of the solute is more than concentration of the solvent in 1:1 ratio, it is let us it is 1:2 ratio. That means the excess solute is remains as precipitate in the solution. If this process is carried out in an appropriately selected solvent and in a controlled manner, it can lead to crystallization. As we know, crystallization is a process where evaporation is followed by crystallization, where we find the or we determine the crystallization point by blowing the glass rod. Now, this is general experiment in class 11 or 12 class. Uh, so precipitation can be brought about in a manner of ways. So this is your solubility part. Then we have partition. In partition, the method based on partition requires two phases, like your one is your mobile phase and another will be your solid phase. Okay, so partition is just same as your chromatography method. So in chromatography, there is a mobile phase and there is a static phase or solid phase. So if I go for an example, then we have a liquid chromatography. That means the solid, the static phase is a liquid and also the mobile phase is also liquid. Then we have gas liquid chromatography and so on. So in partition property, we will discuss different types of chromatography. Then we have the next part, that is ion exchange, where the ions are exchanged, and this property, with the help of this property, we will separate the constituents from its mixture. So in ion exchange, there is an exchange of ions, that means cation or anion. So between an insoluble solid material and the solution in contact with it. The solid material called ion exchanger carriers exchangeable cation and anions. When the exchangers is in contact with an electrolyte, these ions can be exchanged for a stoichiometrically equivalent amount of other ion of same charges. That means we will use some solid materials to separate the constituent ions on the basis of ion exchange, where Ions like cation or anions are exchanged with the supplied external solid material. Then we have surface activity. As we know, the surface activity we have adsorption process, where the adsorbate molecules like the foreign molecules gets adsorbed on the surface of adsorbent, like your uh, water vapors are adsorbed on charcoal. That means charcoal is your adsorbate and water vapors are your adsorbent. So by the property of your surface activity, that is by the phenomenon of adsorption, we also separate the constituents from its mixture. Then we have molecular geometry. Then in molecular geometry, we there are a number of methods based on molecular geometry. They require a permeable barrier to provide separation. The methods are molecular sieves, gel filtration, and the membranes like microporous membranes, homogeneous membranes, charged membranes, thin membranes. These are used for the separation of constituents on the basis of molecular geometry. That means the separation depends on its geometry or shape. Then electromigration, as we know, electromigration is just the same as your electrolysis process, which is based on Faraday's law, where anode and cathodes are present and the respective ions are moved to their respective electrodes by the supply of external electricity. So this is we will discuss electromigration details in our later part. So these are the properties on which the separation technique is classified, that are volatility, solubility, then is your partition, that is chromatography, ion exchange with some external solid materials and ions like cation anions are exchanged. Then we have surface activity, that is phenomenon of adsorption, molecular geometry, where some membranes are required to separate the constituents. Then we have electromigration. This is based on your electrolysis process, that is that follows your Faraday's law of electricity generally. Then we have classification based on equilibrium. So classification based on equilibrium, then there is an equilibrium which defines the classification of separation techniques. This depends upon the type of equilibrium. So different types of separation methods have been classified under various categories based on property resulting into separation. Practically, all these methods can be divided into various classes using equilibrium and rate processes as a criteria. So we have another type of classification based on rate processes or its kinetics. The equilibrium process are based on difference in the property of individual components. These processes are generally based on phase equilibria and involve the distribution of substances between two phases. Rate processes are based on kinetic property and equilibrium process based on your equilibrium state. So we have generally four types of classification based on equilibrium. That is your gas liquid equilibrium, then is your gas solid equilibrium, liquid liquid equilibrium, and liquid solid equilibrium. So let's go to first one, gas solid. So some of the important methods in which gas and liquids at the two phases involved are non-chromatographic method, that is your distillation method, where gas and liquid both these states are involved, where liquid is the ordinary water we have taken for distillation of water, and gas is the water vapor formed by the evaporation process. So the equilibrium is between your gas and liquid in distillation process. Then the second one is your chromatographic method. One is there, that is gas liquid chromatography, where the liquid is your static phase and gas is your mobile phase, and there will be separation of mixture based on the interaction of the constituents with the mobile and static phase in your gas liquid chromatography. Then the second one will be your gas solid equilibrium. In gas solid, the example is your sublimation, where the constituent is directly changed from solid to gas without attending the liquid state. That means it is the direct conversion of solid to liquid. So this is known as sublimation. And another phenomenon is there, that is the adsorption process, where the gaseous adsorbate are adsorbed on the surface of the adsorbent, that is the solid. That means where the solid is the adsorbent and gases are the adsorbate particles. So this is also the phenomenon of adsorption. Then in chromatography, we have gas solid chromatography and exclusion chromatography. So both these chromatography belongs to your gas solid equilibrium, which is the second type. The third one is your liquid liquid equilibrium, where liquid liquid extraction will be one process, and liquid liquid column chromatography, liquid liquid planar chromatography, and the last one, an advanced process, that is HPLC, high pressure liquid chromatography phenomenon, is based on the liquid liquid equilibrium process. And the last one will be the liquid solid chromatography. Uh, this liquid solid chromatography, in a non chromatographic method, it is a precipitation method, where excess solid is remain undissolved, and this will form the precipitation. Then we have fractional crystallization also. This involve liquid solid. And in chromatography process, we have adsorption chromatography, ion exchange chromatography, affinity chromatography, and exclusion gel permeation chromatography. So these are the four types of equilibrium processes, which defines different types of separation techniques. That is a four types: gas liquid, gas solid, liquid liquid, and liquid solid. Then classification based on rate processes. So how the kinetic property of the components of the mixture is defines or is helpful in separating the constituents from a mixture. So it is based on the kinetic properties, that is the rate processes. So this is mainly of two types, that is your different diffusion rates through permeable barriers such as membranes, and the second one is different migration velocities under various fields like electrical, gravitational, and thermal field. So let's come to the first point, that is different diffusion rates through permeable barriers. So the most commonly used permeable membrane is semi-permeable membrane. So what is SPM? That is semi-permeable membrane. Just like if you have experienced a boiled egg, in boiled egg there is a thin layer of uh, there is a thin layer which is very much different from the surface of the boiled egg. Very thin layer, which is a semi-permeable membrane. So semi-permeable membrane is used, uh, is based on the on its use are ultrafiltration. It is used reverse osmosis, like your in water purifiers, in aquaguard, Kent purifier. One property is there, that is known as RO. RO stands for your reverse osmosis, where the reverse osmosis process is supposed to happen, and your dissolved solids or unwanted particles in your ordinary water gets filtered, and you will get purest form of water to drink. Then in this permeable barrier section, we have the third part, the dialysis process, and the last one will be electrodialysis process. Then the second one is a field separation. In field separation, we will apply some external energy in the form of electrical, gravitational, or thermal. So by the application of the external energy, we will have electrodeposition, that is same as your electrolysis, that is Faraday's first or Faraday's law. Then we will have electrophoresis. This is also a separate unit in this paper. Electrophoresis means your movement of ions to their respective electrodes by by the application of external electric field. This is also one unique phenomenon of your electrochemistry, that is electrophoresis. Then we have capillary electrophoresis. Then electrochromatography is also there, which is based on your migration or velocities under your electrical field. Then separation due to gravitational and thermal fields are elect ultracentrifugation and thermal diffusion. We will discuss this in our next slides. Ultracentrifugation, that is centrifuge, and thermal diffusion. So students, am I audible, or is there any problem? Please.
No, sir.
Okay, okay. My slides are very much visible to all.
Yes, no, sir. Slides are not visible.
Not visible.
Slide.
No, it is visible. Visible.
It is visible.
Okay, okay, okay.
It.
So, till now, everything is okay, or am I too fast to clarify your theories? It is okay, and you are understanding
Oh,
the things.
yes, yes, sir. Yes, sir.
Yes, sir.
Okay, these
Till
are
now, everything
actually
is okay.
okay. Actually, these are not a theoretical section in chemistry. These are all practical session.
Yes, sir.
So I am going very slowly from basic part or fundamental parts to the depth part, and just be with me, and anything you have to ask in any point, you may place your question in the chat box, or you may ask me directly. Okay.
Okay,
So
sir.
okay, okay, okay. So this is the classification of the separation technique based on the in its kinetic property. That is the rate or the migration of the constituent particles towards a respective part by application of some membrane, like your semi-permeable membrane, and different external fields like your electrical, gravitational, or thermal fields. Then we have the general things, that the methods of separating mixtures. What are the methods? The first one is a magnet. Magnet is a very good magnetism is a very good property, or very useful property to separate like your ferry or antiferromagnetic substances from a mixture, right? So magnet. Then we have filter, that is very much the simple technique. Filtration, we will need a funnel, a filter paper, some container, and also in a chemistry lab we used glass rods to filter a solution. Then we have a decantation process. In decantation, you just decant the upper part of the upper part of the component that is in liquid state,
and you will separate the solid part by simple decantation. Then evaporation, as we know, this is the application by application of heat. The liquids, or the, if it is a solution, it will get evaporated on the uh, basis of its volatility. So high volatility substance will evaporate first. Centrifuge, already told, this is just a application of your gravitational or thermal field. Centrifuge. Then the very important, that is chromatography. This will be the best separation technique, which based on your static and mobile phase. We will have a discussion on this. Then the distillation process, as we already know, the distillation, we have ordinary water to distilled water or double distilled water, through evaporation and followed by condensation. So this is just a pictorial form or a demonstration of your filtration process, where uh, this is the mixture of solid and liquid in a beaker, and this is just a scientific way to place different apparatus in filtration process, where this stand is known as a filtration stand, and the cone shape apparatus is the funnel, and we have which is in which filter paper is set, and under it this is also another beaker. Then with the help of staring rod or the glass rod, we will separate the solid particles or solid constituents from its solution. So this is the distillation process. In school time, we it is there in our school books also, where where some external heat is supplied to the round bottom flask, which contain the ordinary water, and this water gets evaporated, and the water vapors are through this condenser, so which is connected to cooling water. These 2 points are cooling water points, where cold water is flows through this, and the water vapor gets inside, gets cooled, and it again converted to ordinary water, sorry, converted to liquid state. Then we have mechanical separation or physical separation. This is separation by hand. Just you have something like this, some balls or pebbles of different colors. If i um, if i tell you to separate the these balls on the basis of its color, then you will able to separate it with the help of your hand very easily. And like this, recycling plastic, paper, metals can be separated from a mixture by mechanical separation or physical separation, or this is very in general, this is by hand. Then we have the magnetic separation, where we use the property of magnetism to separate uh, ferromagnetic, ferrimagnetic, or uh, that is um, that is materials which have magnetic properties, like which undergoes your iron, nickel um, family. Okay, so this is an example where sulfur and iron fillings are mixed, and from this mixture, by with the use of a magnet, the iron fillings are separated, and sulfur is gets purified. Okay, then we have a filtration separates a liquid from a solid, as I have already explained you. This is just a simple filtration process, where this is used mostly in scientific experiments for separation. Then this is the filtration. which takes advantages of the physical property of the states of matter. A screen lets the liquid particles through but trap the solid particles. That is our filter paper. Then this is the solution we have put on this filter paper, where undissolved particles are there, and the soluble particles gets passed through this filter paper through these boards or pores, and we will get the pure liquid. This is the method of decantation. You just incline the container and separate the upper surface liquid, and you have the bottom solid part separated by the process of decantation. So decantation is to pour off a liquid, leaving another liquid or solid behind. So if two liquids are there, then on the basis of its density, which have higher density, this will be at the bottom, which have lower density, this will at the upper part of the mixture. Then lower density will be separated first, followed by the second. So in this process of decantation, we will separate liquid from solid or liquid from liquid. So this is just an example of decantation of liquid from a precipitate or water from rice. So this is just a separation by decantation. Then we have the chromatography, very interesting, and also this is very much a separate unit in your MCH-002 paper, that is the chromatography method. So chromatography we used two two states, that is there are two phases, that is mobile phase and static phase. So the in gas liquid chromatography we have gas is the mobile phase and liquid is the static phase. So depending upon its volatility, it defines the static and mobile phase in a chromatography. So this chromatography process is used to dye t-shirts. Dye means coloring. So coloring of t-shirt and a black pen ink. Then we have DNA testing, which include your tomb of unknown soldiers, crime scene, paternity testing. These all include your chromatography application. Then we have evolution of chromatography. How this process is developed, or from where it is started. Now this process was started by, or it was reported by, a Russian botanist, Mikhail Sweat. This is his picture, and in 1906, he was the first to have observation in chromatography. So, so the subject of chromatography had a very modest beginning. The principle and the application were reported in 1906 by a Russian botanist, Mikhail Sweat. How he develop or report this process. He described the resolution of chlorophyll and other plant pigments in a plant extract. A petroleum ether solution of chlorophyll was passed through a calcium carbonate column. By passing the solvent through the column, the pigments were resolved into various zones. This separation becomes practical if after the pigment solution. That means uh, he um, used the chlorophyll uh, pigments in a plant extract, and pass through it in calcium carbonate column. That means here the calcium carbonate is your static phase, and he used the mixture your plant extract, that is in liquid phase. That means it is a liquid phase is your mobile phase, and calcium carbonate is your solid static phase. So he observed the pigments are separated uh, through a various segments, and he reported this phenomenon, and his idea was extended or was advanced by two scientists, james and martin james and martin and they use this technique in various applications in a scientific field, and in 1952 they were awarded the Nobel Prize for chromatography. So, just remember this scientist name. You may write in your examination that is related to your chromatography. Then this is an example of paper chromatography, where there is a chromatography paper that this is known as a TLC paper, thin layer chromatography, where and this chamber, it is known as chromatogram, right? And this is a single paper which is equally divided into three parts, and at the bottom there are three crosses are there. Then what happened to next? We put here a single line. Then the samples are placed at three points, that is one red, one green, and one black sample. Okay, so these are three samples. So these samples are, let us, I have one reaction, that is a reactant to product. Then what are the three the three samples here? The first one may be your reactant, the second one may be your product, and the third one is the mixture of reactant and product. So this is reactant, this is product, and this is mixture of reactant and product. And we have the, this is the static phase. And what is a mobile phase? Mobile phase is inside there is a liquid. This liquid is generally ether or hexane. Okay, so if I put this TLC, thin layer chromatography paper, in a chromatogram chamber in ether hexane solvent or mobile phase, then what happen? Just see what happened. This is the first one is the reactant, red one. Second one is the product, green one. Third one is the mixture of product and reactant. Then what happened? There is a movement of constituent from the mixture by highlighting some regions with definite colors. That, so it indicates, so the here there is a red, that means what happened? This reactant also has two components. This product has a reactant part and another different byproduct. And the third one, it is a mixture of both. So we have a product here and a reactant here, and also a byproduct. That means what happened? This separates the constituents present in the mixture by chromatography application. How chromatography application? We have a thin layer chromatography paper which is equally divided, and at the bottom we placed a straight line and we put three samples. One is my reaction reactant, second one is the product I obtained, and third one is the mixture of reactant and product. Then then if I put this TLC in a chromatogram in the solvent, it depends. Okay, and depending upon your type of reactant and product, but in general ether and hexane mixture, or only ether is used for separating the constituents from its separate mixture. Then if I put this paper here and close the mouth with a lid. Then the constituents, just see, just see, the constituents get separated after few time, like this. Just see, this will go on up and up. Then we have spots at TLC paper, and um, by seeing these colors, we may conclude what type of constituents are there. And just remember one thing: um, the this red color above and yellow color is below. That means that means the solid phase, that is TLC paper. The solid phase, this yellow component has more affinity than the red component. That means in ionic term or electrovalent term, you may we may we may conclude that yellow has, it is more polar or more ionic than this, because if the ionic character or the polarity is more, so there will be more attachment of this constituent to the static phase. So that's why the constituents which are below, these three which are below, they have more attachment to the static phase as compared to this red component which have lower polarity. Okay. So then we have this one, column chromatography. This is just a separation by chromatography. Just see this one. This is the reaction mixture or the sample sorry, this is the sample mixture we will put here, and this is the static phase. Okay, so this is the stationary phase. Bottom one is the stationary phase, and mobile phase is just like your silica gel or something. This is the mobile phase, and this is a detector. Then put the mixture if I put the mixture inside the chromatogram, then what happens? Just see. If I put the mixture in the column, and after that, if I add the mobile phase, that is your ether or hexane, then continuously the sample mixture gets floated or continue to move, and after that the constituents get separated on the basis of their polarity or ionic character. That the solvent, sorry, the constituent which remove first have less polarity, followed by this red one, this blue one, and this yellow, three particles of yellow. These three will have the maximum polarity, and they will separated at last. So this is just a demonstration of your chromatography. Okay. Then we will have ion chromatogram. That is the this is an application of your ion exchange chromatography. In your ion exchange chromatography, this is just a chromatogram of your orange juice, where metallic ions are present like potassium, sodium. These ions are present, and these will be separated on the basis of its ionic character, that is your cation present. So just like this, we will have a chromatogram here. Just see, after 5 minutes, almost after 5 to 6 minutes, we will separate sodium plus ion, then followed by K plus, magnesium, iron, and calcium. So this will be your ion exchange chromatography or ion chromatography. This is just the evaporation process, where we will supply some external heat to evaporate the less volatile component of our mixture, and the and the high volatile part will remain. Okay, so in a to heat a solution, we will require one Bunsen burner. You may see this one in any general lab. One is your Bunsen burner, and this is known as the stand. Here it is the heating stand. You may say this one the heating stand. We have a wire gauge, just like a net, iron net like material. Then one is your beaker. Just this is the evaporate. Sorry, it is the heating a solution. Then we have the the next part is the distillation apparatus. So this is the distillation apparatus where the ordinary water, or if this is a mixture of liquid with a solid dissolved in it. This one, this is a supply heat, that is by using your burner, and we put here a thermometer to measure the temperature, and we have the condenser part here from this point to this point. It is the total set is the condenser. Then we have ordinary water inlet, and we have the a conical flask, which is the receiving flask. Okay, so this is just a general process. When heating is when the heat is applied, there will be evaporation of the liquid, and it will be converted to liquid to gaseous form, and these gaseous vapors will be moved through this channel, and it will be enter this condenser. And when this pass through this condenser, and cold water is supplied, this will be condensed from gaseous to liquid state, and we uh, will have the pure liquid or distilled liquid from this process. This is uh, this is just a sample of salt water. So if I evaporate this sample, then the water gets collected here after purification or distillation, there, and the remaining will be the salt. Just see this one, there will be a salt, only salt is there here. Salt with water, or this is a salt solution, and when I distilled under distillation process, we will have only salt part. Okay, so salt is here and pure water is here. Okay, so next one, salt water solution. No chemical change occur when salt water is distilled. That means when salt water gets distilled or separated, no chemical reaction will occur, and we will have a homogeneous mixture, that is the solvent and solute both are in same state, that is the homogeneous mixture. And when salts gets dissolved in water, there is no chemical change occur, only the dissociation of the salt occur. When I mixed sodium chloride salt water, what happened? The sodium chloride gets dissociated to give Na plus and OH, Cl minus, chloride ion. And when I evaporate the salt solution, and I separate the water, then I will again get the salt in the container. So there will be no chemical change occur, how it's supposed to be happen when salt gets dissolved in water. Then this is a separation of a salt sand water mixture. Here what happened? Sand is there, salt is there, and water is there. So three components are there. So how we will separate these three components? We will separate these three by, the first one will be the physical method, by decantation or by filtration. If I decant or filtrate, then the sand and the salt water gets separated first. Then we have sand in the first component and salt water as our second part. So the second part is undergo distillation process, evaporation followed by condensation. Then we have the salt and pure water. So
by filtration or decantation, followed by distillation. We will get the three components, that is solid, that is sand, and is your salt and pure water. Then this is very much the simple things. You may just, I am reading this one. Uh, Separation of sand from salt. How sand and salts are get separated. Salt crushed into sand, wet the mixture, pour into heat resistance container, fill with water, stir and let settle 1 minute, decant clear liquid, wet sand, repeat 3 times. If no, then continue this process. If yes, evaporate, dry sand, wet, and calculate the weight of the salt. That means, where in the previous case, just see this one. Um, if I say this salt solution, this may contain some sand. So how to separate this sand from this solution, which gets passed through the pores of the filter paper. So to separate these minute particles of the sand from the salt water, we used this process. Just wet the salt solution, then you may wet it, then again add water, then again filter it. Then this is just a general theme to separate sand from salt. Then this is very much interesting. That is as I already told, that your distillation part is your 5 types. That is your fractional distillation, flash distillation, vacuum distillation, steam distillation, and azeotropic distillation. So first one, fractional distillation. In fractional distillation, what happens? It involves the return of condensate to the distillation unit under condition such that this condensate is continuously and counter currently in contact with vapor. By this method, you can achieve greater enrichment of vapors of more volatile component than that obtained by simple distillation. That means here the vapor or the vapor formed is again back to the distillation chamber, and it gets again evaporated, and we will get the purest form of your component. Then flash distillation, there is an instantaneous and continuous vaporization of a definite component of the mixture, such that the total vapor produced is in equilibrium with the remaining liquid. So this is known as your instantaneous and continuous vaporization. This is known as your flash distillation. Then vacuum. In vacuum distillation process, this is supposed to be happen in reduced pressure, under reduced pressure. It is used to separate high boiling mixture or liquids that decompose below their normal boiling point, and low pressure reduces the boiling point. So when pressure reduced, the boiling point reduced. So when boiling point reduces, the volatile character increases. So when the volatile character increases, there will be the separation becomes more easy. Okay. Then steam distillation is employed to separate a component from a non-volatile impurity. The boiling point of the mixture is reduced by vaporizing it in a stream of carrier vapors. May say steam with condensation is immiscible with the original mixture. And the last one is your azeotropic distillation, where azeotropic means liquids with nearly same or same boiling point is known as azeotropic mixture. That is, the components or the constituents have nearly same or same boiling point. So this process is used for that type of mixtures. So azeotropic distillation is used for separating components of a mixture which boil very close to each other. The relative volatility of the component of the mixture is altered by adding another substance. Yes, the volatility will be altered by adding a foreign substance. This description will give you an idea about the different ways of distillation, that is fractional distillation, flash distillation, that is under high heat, vacuum, steam, and azeotropic distillation. Then the next will be your centrifuge or centrifugation. It is the application base, that is a gravitational or thermal field application. There is a there is a circular motion with high speed. Okay, so where a circular motion with high speed is supposed to be happen, this mixture gets mixed and separated on the basis of its density, where the denser part will be at the bottom and the less denser part will be at the upper part of the solution. So this technique is used to for blood test, for DNA test, etc. Just see this one. This is a spin sample very rapidly. This rotation is known as speed. So in centrifugation, spin sample very rapidly, that is very rapidly. Denser material go to bottom or outside. As I already told you that denser material or more dense will be remain at the bottom, and which have lesser density they will be at the upper part of this uh, container. Okay, so separate blood into serum and plasma. Just see this one. This is sample A. This is before. No centrifugation is supposed to be happen. Then after centrifugation, that means if I put my sample here, then by faster rotation and spin, the components gets separated on the basis of their density, like this. Then we have your red blood cells, then serum. So this is the after situation. This is the before solution. Okay, and this test is used to check if you have anemia, that is a lack of iron or not. Then we will move to electromigration or electrolysis. So this is based on your Faraday's law. So this law states that uh, the quantity of substance deposited or liberated during electrolysis is directly proportional to the amount of electricity passed through it. That means the amount of substance liberated or deposited at their respective electrodes during electrolysis, that is supply of or application of external electric field. The amount of substance deposited is depends on the quantity of electricity passed through it. So this is just I will demonstrate you how a water molecule gets separated to hydrogen gas and oxygen gas with the application of electrolysis. Uh, so this is these red balls are oxygen and blue are the hydrogen. So one oxygen and two hydrogen gets attached to form the water molecule. Just see the decomposition of two water molecules. So this is two water, that means 2H2O gives rise to 2H2 plus O2. So that's why this is two water. So this is application of electric current. Then we have two water will give two hydrogen and one oxygen molecule. Then this is the electromigration apparatus or electrolysis apparatus, where there are two electrodes here. One this one is this one, and the middle part will be the middle part. There will be only water, which are connected to your external source of electricity. That is one battery is connected, and this process is maintained at high pressure. And okay, and this water, in this water, some acids are added, because in presence of acid only
the water gets separated or dissociated into oxygen and hydrogen. So just see this one. Now this one, the diatomic oxygen molecule O2, and we have diatomic hydrogen. This is 2H2. This is the electrolysis process. So what is electrolysis? Electrolysis is, electro means electricity. Sorry, yes. Electro means electricity, and lysis means to split, to separate. It is lysis. So what happened here? Here, water in presence of acid H plus gets separated or dissociated to oxygen gas and hydrogen gas. And you should remember that water gets dissociated or conduct electricity in presence of acid, because this is the in presence of acid, the polarity or the dipole moment or the charge, partial charges are developed in presence of acid. So water gets dissociated to oxygen and hydrogen in presence of acid. And this is the electrolysis chamber or electrolysis apparatus, where two electrodes are here. Here water is there, and if I connect the source of electricity, then bubblings will be there, and these bubblings or these bubbles shows or represent the formation of hydrogen and oxygen gas, which can be collected through external containers. This is the electrolysis of water again. This is the reaction, half cell reaction, where reduction is supposed to be happen in that is that is your formation of hydrogen, and oxidation will be formation of oxygen O2. So reduction is happen in cathode and oxidation is happen in anode. So in cathode, the half cell reaction will be uh, the water molecule added electron. Someone is unmuted. Please muted. Okay. So in cathodic half cell reaction, reduction happens. A reduction is addition of electron. So water is added by 4 electrons to give 2 hydrogen and 4 hydroxy ions, OH minus. And the reverse process is there in your oxidation process, where liberation or a loss of electron is happen. So water, there will be loss of 4 electrons. We will have oxygen gas and 4 H plus. So again 4 H plus and 4 OH minus will combine, and we will have 4 water molecule at the same container. That means this one. That means from here 4 H plus liberated, from here 4 OH minus liberated, and they will return back and they will have bond and they will form again the water. So this process will continue. H plus OH minus water, and from water oxygen here and hydrogen here. So this is hydrogen means this is a reduction, oxygen means this is oxidation. Hydrogen means it is addition of electron, and oxidation means it is a removal of electron, that is 4 electrons. This is just okay. This is the last part of your unit 1, that is what are the criteria to select a separation method for a particular mixture. Okay, so this is the separation, the selection of separation methods for a particular separation. Then we have the first criteria will be your selectivity. Second will be detectability. Third one will be yield, speed, and convenience. Fourth one is capability for hyphenation, and the last one is ease in scaling up and economics. So I just give you uh, 2 to 3 minutes
to ask something, or you have any, if you have any doubt or something to ask, so please you may, then we will move. Anyone have any doubt? These are very much simple and practical things. Just we are very much unfortunate that we studied this one theoretically, but these are practical things. Anyone have any doubt, or else we will move on. Mm, okay. 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 Let's have our next. Sorry. My slide is visible to you, students.
Yes, sir.
Okay. So how we select separation methods? Which type of separation method we may apply or use to separate our constituents from the mixture? The different criteria will the selectivity, detectability, yield, speed and convenience, capability for hyphenation, and the last one will be each in scaling up and economics. The first one is selectivity. In selectivity, we have the foremost and most important is the selectivity, because if I select a wrong separation method for a particular reaction mixture, then the separation is not so effective and we doesn't have the desired result. So that's why the selection of separation method is very much important for separating the constituents from the mixture. The selectivity relates to the capability of the techniques to separate the desired components effectively from a complex mixture, particularly containing closely similar components. This is very important. If our mixture contains closely similar components, like your azeotropic mixture, where just hold on. Hello. Uh, I'm so sorry for the interruption, students. So in selectivity part, we have closely similar components. For example, we have mm, let us we have azeotropic mixture, where the components have nearly same or same boiling point. So before choosing a separation technique for a particular mixture, we will have a broad knowledge on the different separation methods which are very much available to us. The term effective separation is expressed in terms of resolution, separation factor, decontamination factor, and percentage of purity. So selectivity is the main factor, or is the primary factor to separate constituents from its mixture. Then we have detectability. Sorry. What happened? Okay. Then we have detectability. The term detectability refers to the minimum amount that can be detected. This is also an important factor. It is also termed as sensitivity. Detectability is otherwise known as sensitivity. In the case of detectors, it can be calculated based on certain assumptions, such as detection at 2 or 3 times to noise level observed at the baseline. Sensitivity can also be determined practically. Sensitivity or detectability can be improved by properly optimizing the separation conditions using the same detector. Sensitivity assumes paramount importance when the quantity of mixture to be analyzed is very small or trace impurity for obtaining an ultra pure material are to be assessed. That means detectability or sensitivity is applicable where there will be minimum amount of pure matter or pure substance or component is expected to come. If we have a small quantity or we have a small amount of pure material is present in our mixture, then sensitivity or detectability plays a prime role in separation. Then we have uh, yield, speed, and convenience. We have another parameter is also there, reproducibility. Here it is not written. The third one is your reproducibility. The reproducibility means the result reproduced again and again. This is known as reproducibility. The method should be such that it gives reproducible results for separation. It is usually expressed in terms of standard deviation or coefficient of variation based on replicate measurements. That means the same like in simple titration. Okay, so let us for an example, we have acid base titration, acid alkali titration. What happen? We do the same titration process a minimum of 4 times to have the concurrent or the concordant readings. That means the reproducibility of the reading by repeating the same procedure again and again. This is known as reproducibility. Okay, so this is another factor which or criteria for the selection of your separation method, that is the reproducibility. In reproducibility, it is important to point out that the separation condition should not be such that a slight variation in the condition may alter the result significantly. That means when the condition changes slightly, the result also changes vastly. That means when if I did one titration by putting by using let us a 10 ml pipette. In the first iteration, I perform the pipetting very carefully, and I have the control and reading, let us 9.8. Then if I in the second time I do not perform the pipetting step properly, then what happened? The reading may become 9.8 to 9.6 or 9.5. So there will be difference in results. So carefulness or sincerity is very much important for your reproducibility criteria. That every step or every level of experiment you have to be very careful and sincere, the such that you will get same result repeatedly. That is your reproducibility. Then last one, fourth one, yield, speed, and convenience. Yield means it is the amount of substance you will get after the separation process. This is the yield. So, in all these methods, simultaneous quantification of the separated product is done. A quantitative recovery of the separated product is a must. Naturally, a method giving a higher yield is preferred. If I have chosen two separating methods, and from first method I have 8 gram of ultra pure substance, and in the separating and the second method I have got 10 grams of ultra pure substance, then I will prefer method 2 for the separation because it will leads to high yield. Then also the speed is also a important factor. That is, if I take the speed, let us for filtration, I have three different filter papers. The first one is the ordinary filter paper, second one is the Wattman 41 filter paper, third one is the Wattman 42 filter paper. Then what happen if I filter, or if I separate the liquid from the solid in ordinary filter paper, it will be maximum of 1 to 2 minutes, or more maximum 5 minutes. If I filter the same sample in Wattman 41, it will take around 15 to 20 minutes, and in 42 it will take another 10 or 15 minutes. So it depends on the type of sample you filter or type of sample you separate, and on the basis of the speed or the recovery or the separation, you have to choose the separation method accordingly. And the fourth one is the convenience. Convenience is also very important. That is in a decantation process, we saw the separation of water from rice. So what is the convenient process or step? It is a decantation. If I say you separate rice from water by filtration process, is it convenient? It is not convenient, because in filtration you have to put one funnel, filter paper, then bottom container, then you have to use the glass rod, etc., etc. But this is not the convenient process to separate water from rice. So water from rice, the best or easiest or convenient way to separate is the decantation. Okay, just first time decantation. If something impurity is there, then again add water, then again decantation. This is the easiest way. So convenience. So capability for hyphenation. So in a majority of chromatographic method, there is a detector which quantifies the effluent coming out of the column. Effluent means it is the constituents. These detectors are not very sensitive. Also, they have a limited capability of identifying unknown. It is known that a mass spectrometer is a very important, powerful universal detector. That is GCMS, gas chromatography mass spectroscopy. So, which is used in our satellites, Chandrayaan 3. In Chandrayaan 3 or in any satellite, GCMS is installed, gas chromatography mass spectroscopy, which is very much advanced technique, and which is able to detect what type of material is present at the moon surface, okay, or Mercury surface, and what is the material. This can be detected with the help of GCMS, that is gas chromatography mass spectroscopy. The gas chromatography is an ideal separator, whereas mass spectroscopy is an excellent for identification, right? The main aim of an interfacing arrangement is to operate both a gas chromatograph and mass spectrometer without affecting the performance of either instrument. The problem is the problem is compatibility. The interface provides the link between the two instruments. So the technique like high performance liquid chromatography HPLC and simple liquid chromatography LC are coupled with mass spectrometer, that is in GCMS. The interfering makes the technique is a powerful tool. Thus, in nutshell, a separation technique is convenient interface with an effective detecting device like mass spectrometer. This can be an additional advantage of the technique. There have been serious efforts in the direction and even in the sample. So, but this is capability of the hyphenation. Okay, means it is the use of advanced technique to separate or to detect the constituent or the substance present in a particular area or a sample. And the last one, ease in scaling up and economics. This is very important. Ease in scaling, that we have to scale what type of substance is separating, and economics is a very important part, because in economics, let us we know minerals. There are two types of things are there, that is minerals and ores. Mineral and ores. Uh, all minerals are not ores, but all ores are minerals. What is the difference? Because ores are the economic form of mineral. This is known as ore. So all minerals are not ores. For example, if I found a mineral from earth crust, and after chemical processing and all other advanced technique, I found the mineral contain gold. Okay, so after separation and purification, I found, let us 10 gram of gold. So the value of 10 gram gold in market value, the market value of 10 gram gold is nowadays in today, it will be nearly 60 to 65,000. Okay. So if I expended let us 1 lakh for the to separate the gold from the mineral, then that mineral is not is considered as ore, because I have spent 1 lakh rupees, and I have only 60 to 65,000 of gold. So this is not economic. So if it is not economic, so this is not an ore. If it is economic, that means I have got 60 to 65,000 of gold, and I have an expenditure of around let us 20,000. I expended 20,000 and I received 60,000. So that mineral is now known as ore. Similarly, if I choose a separation method for a particular sample mixture, then I have to consider both the scaling and the economic part. Just I read the paragraph. It has been repeatedly pointed out that one of the main role of separation technology is the synthesis part, which is the recovery of purified product. Therefore, the separation method do not remain unnecessarily confined to bench scale. The basic data has to be used to scale up the process to plant scale, and one important part is your economic part. And your separation method should be a commercial method of separation, and it should be environmental friendly procedure. Okay, so this must be economic and ease in scaling with environmental friendly procedure. So this is all about your unit 1, and I think I cover all the parts that have highlighted or there in your PDF, IGNO PDF. I follow both. Okay, right, in my presentation I have some PPTs, and which I have coordinated or with your PDF which you have supplied from your IGNO site, and this is your unit 1. So we will move to unit 2, and if you have any doubt, you may ask me now. So it is open to all, so one by one you may ask. And this is very much common processes, and these are all practical things. Okay, and few methods are school levels, that is distillation process, then filtration process, then we have like your volatility, solubility. These are all very much simple techniques which are used. Okay, so next to our second slide. Sorry. Okay, so we have the second part, that is the solvent extraction. Just wait. Okay, so I think it is very much visible, students.
Sir. Yes, sir.
Okay, okay, thank you. So your unit 2 is solvent extraction. So in this part, I will not go through your PDF. I will explain you in this PPT, PowerPoint presentation. So just I will give you homework that you have to correlate, or you have to study, or you have to see your PDF and correlate my PPT to your PDF. So this is solvent extraction. As we know, solvent, it is generally in the liquid state. Solvent may be primarily it is liquid, but in some cases it may gas, and solid solvent is very rare. So in the world of chemicals, a substance is rarely found in pure form. Also, whatever may be the method of precipitation, a chemical entity is the truest sense is never obtained, and all these are in mixture. So this is the first one. Then what are the content? We have introduction, solvent extraction principle, distribution coefficient, distribution ratio, a relation between distribution coefficient and distribution ratio, factor affecting solvent extraction, separation factor, batch extraction, counter current extraction, application of solvent extraction, and we have some numerical problems. So solvent extraction is also called liquid extraction and partitioning. So immiscible liquids are one of the more one that cannot be get mixed together due to difference in their densities, and they form two separate layers, right? If we mixed water to any organic solvent like benzene, ether, hexane, uh, these are the organic solvents. If I mixed inorganic solvent like water to organic solvent like benzene, then what happened? Due to difference in density, we have two layers. Just see this one. Yes, just see this one. This one, this type. Just see, this is the first. I have taken 0.50 gram of liquid one. Then I have added 0.29 of second liquid. Then I thoroughly mixed it. So what happened? The denser liquid will be at the bottom and less denser will be at the upper part. Then through this channel, I have a key here. By opening this key, we will separate the denser liquid first. That is the aqueous part. Between the aqueous, that is water and ether, water has higher density than ether. So ether is above and water is below. So this is the separation of solvents. That is, water is removed first or separated first, followed by the ether. Okay, this apparatus is known as separating funnel. Okay, so we will have this one. Then solvent extraction is a process in which a compound transfers from one solvent to another owing to the difference in solubility or distribution coefficient between these two immiscibles. That means two solvents are not immiscible. It is a method of quantitative separation of compounds. When extracting solvent is stirred with solution containing solute, then solute from original solvent gets transferred into an extracting solvent, right? So that means the two solvents are stirred well. The stirred well means mixed well, and they will be separated on the basis of their density, and the high density solvent will separate it first. Okay, when stirring is stopped, extracting solvent from separating layer, and now it contains solute of interest. Compared with other separation method, it gives a better separation effect
than chemical precipitation and a higher degree of selectivity and faster mass transfer than the ion exchange method. Compared with distillation, solvent extraction has advantages such as low energy consumption, large production capacity, fast action, easy continuous operation, and ease of automation. With respect to distillation, where external heat energy is required, then different apparatuses are required. But in your separating funnel, only one apparatus is required, that is a separating funnel. You will put your solvent one by one, then by hand, with your hand, that mixed it vigorously or smoothly, then by after some time the solvents are separated on the basis of their solid density. Then compared with distillation, this will have low energy consumption, no energy is consumed. The production capability is also more, because there will be no chemical or physical change of the solvent. This is also fast action. The time is also less time is required, and this is a easy continuous operation, and automation is also easy. So commonly used solvents, just see: ethyl acetate 8.1%, diethyl ether 6.9%, dichloromethane 1.3%, chloroform. The formula of chloroform is CHCl3. It is 0.8% dissolved in 10% water. That means in 10% of water, these are the percentage of ethyl. That means with respect to water, with respect to water, these all have lesser density. Okay. Water also dissolve in organic solvents like ethyl acetate 3%, diethyl ether 1.4%. Just remember the solvent names. Okay, you will have a question from the names of the solvent, and you will not required to remember these things, these numbers. This is not required. Just remember, organic solvents have generally, organic solvents have lesser density than water. Use of solvent extraction process. Solvent extraction is used in the process of perfumes, vegetable oils, or biodiesel. It is also used to recover plutonium from irradiated nuclear fuel, a process which is usually called nuclear reprocessing. The recovered plutonium can then be reused as nuclear fuel. Then property of the solvent used for solvent extraction. The solvent should be well miscible with the liquid to be extracted. The solvent should not be miscible with the other component of the mixture or react with the solute. The boiling point of the solvent should be low enough below the melting point of the solute, such that it can be evaporated easily, and it should have a favorable temperature coefficient. So these are the properties of the solvent which is used for solvent extraction. That means the solvent which we use to separate from the solute or solvent, this must not have any chemical reaction, must not have higher boiling point, it should be have a favorable temperature coefficient, etc. The solvent should be able to dissolve at least one component to a large extent than the rest components in a mixture. The reaction taking place should be stable and irreversible. Reversible reaction can bring up dissolved. It is very much common that the reaction take place between solvent and solute, or solvent should be irreversible. If it is reversible, then again the original component will reappear. Okay. The compound formed after the reaction should be easily separated from the extracted compound so that it can be reused. The density of the compound should be different from the required component to help the separation readily. It should be inexpensive and cost effective. The solvent should not be toxic or corrosive, as it can harm the extraction instruments. Other factors that are it should have viscosity, boiling point, flammability. we should have these things also. Okay, this will be cost effective, less corrosive, less toxic, etc. Then we have distribution coefficient, which is very much important. And one thing you must remember, that the solvent extraction or solvent separation is carried out on the basis of your phase rule. Different phases, in a simple term, the phase means it is the states, that solid state, liquid state, or gaseous state. This is known as solid phase, liquid phase, and gaseous phase. So there is a phase rule, that is F equal to C minus P plus 2, where F is the degree of freedom, or it is otherwise known as variance, and P is your number of phases, T is the number of component, and there is a standard rule, that is phase equilibrium. There is one chemistry unit, that is phase equilibrium, and there is a phase rule, that is F equal to T minus P plus 2. Okay, so phase rule is very much important to explain the solvent extraction. And this distribution coefficient, so I think this distribution coefficient we will discuss in tomorrow's class, and we will have distribution coefficient followed by your unit 3, that is the chromatography. Okay, so I think your unit 3 is chromatography. Just wait. Yes, no, unit 3 is solvent extraction 2. Okay, so we will have from tomorrow's class, we have a distribution coefficient followed by your solvent extraction 2 process. And again I again I uh, again I tell you, if anyone have any doubt or anything else related to today's class, you may ask, or else or anything related to your PGDSC program, or your practical examination, practical class, anything related to your program, or anything related to this class, you may ask. You have only 5 minutes, so it's to you now. Anyone from Nazrul, Abrar, Nagesh, Ranjan, Mahindra, Dr. Rajkumar, Somnath? Actually,
Yes, sir.
students, yes, actually, if you do not ask anything, and it is only one-sided class, that means the supply is from one side, and there will be the second end is the receiver. There will be no charm in the class. You should have asked something. It may be a general question, but if you ask something, then I will feel that I teach you something. Okay, so
Okay, sir.
okay, before you attend the class, I have one suggestion, that you should go through your PDF. What
Okay,
are
sir.
the things they are in your PDF, and what I have taught to you, and what are the differences, what are the similarities you have facing, or any problem you are facing, that there should be a interaction. If no interaction, there will be no charm in the class. Okay, so I hope
Okay.
in the next class we will have a good interaction, and we will continue from that. That is the distribution law. Okay, students.
Okay, sir.
Okay, again I ask you, if you have any doubt or something, or anything related to your program also. Left, just forget today's class. Anything
Sir,
related to your program? Yes, yes, yes.
I have a question.
Yeah, Ranjan.
Sir,
Yes.
today is my first class that I am attending.
Okay.
I just want to know, today was yours first class or it was a second day?
No, no. Yeah, today is the first class. Okay.
Today is
So
the first class. So we have, okay,
I will continue 7 classes for this paper, MCH
okay,
002 paper, second paper, 7 classes.
Just hold. You may take one screenshot. I just sharing. Wait. Yes, this one. You just see this one. These are the dates. That is 27 is today. Then 28, 31, 1, 2, 3, 4. I have continuous 7 classes for this MCH-2 paper separation method. Okay. Then
Okay.
from 7th August, you have MCH-1 paper. That means it will be your resource person will be Dr. Rajesh Kumar Sahu, and he will be available to you from 7th August, because Dr. Monalisa Mahapatra already took 7 classes from 18 July to 26 July. That means yesterday. She has the last class. Okay.
Yes,
So
sir.
these two sessions gets interchanged, but I have two papers, that is your second paper and fourth paper, and today I have we have the first class 27 July, the separation method class 1, then it is followed by tomorrow, then 31st 1 2 3 4, then I will have take some rest. Rajesh sir will take your class from 7th August to 16 August, and from 17 August again I will taught you MCS 4 paper. Okay.
Okay,
Okay.
sir.
Okay.
Sir,
Anything
as
else?
you told, yeah,
Yes.
as you
Yes.
told that this is what you are taking as a practical aspects of the chapters, not theoretical aspects, right?
No, not like this. Actually,
Hmm.
your PG diploma in analytical chemistry, this course is just a practical related course, but you have to face theory paper. So
Correct, correct.
just remember one thing. The whole thing you study in PGDSC, all these are practicals, but you have to study it, remember it through theoretically.
Okay, in that sense, you were saying okay. Okay.
Yes. And you have also, I think you have four practical papers also there. MCHL 001 2 3 4, and one paper there is a chromatography paper. One there is your simple titration. Third one is your like your quantitative assessment of this is your separation techniques. So these are the techniques we will have in our practical papers. Okay.
Okay, so one more thing. This practical papers will happen after we will give this theory examination. Is this mandatory, or whether we can give practical examinations rather
No.
than?
Actually, practical in the last year, the practical examination was held, I think, in April. Okay. So
Mhm.
yearly the respective regional centers have the role to play. This year, RC Bhubaneswar conducted PGDSC practical examination. So
Okay,
and this year also PGDSC theory classes conducted by RC Bhubaneswar. So maybe in the next year, this theory paper may be charged over to RC Patna, RC Delhi. Okay. So
RC Delhi. Okay,
all over the India, there is shuffling of classes, theory as well as practical. So
so I
in
will be sorry to interrupt.
yes.
Yeah, actually, I will be attempting in December the theory papers. So when I will have to appear in this practical examination,
So
I will have because I am
okay. Related to your practical examination, you will
hmm,
receive a mail from the
okay,
RCs. So when and where and in which mode, online mode or offline mode, your practical examination will be held. Okay.
okay,
So
okay,
due to last COVID period, these practical examinations are conducted in online forum. Before that,
okay,
we have a practical examination physically.
Okay, sir.
So this depends which RC conducted your practical examination and what are the instruction they receive from your head office Delhi. This depends. Okay. So my suggestion is nothing to worry about your practical examination, because any RC conducted the examination, you will receive the email, and
Okay.
you should check your mail once in a week, must,
Okay.
because in the last practical examination, uh, I think in PGDSC, only 30 to 40% students appear the examination. 50 to 60% or 70% students do not appear, and
Hmm.
all have received the mail. And if 30-40% student came, so why not 60-70 students got left? Okay, so these things happened, and they told that, sir, we do not get any message, we have no mail ID. These things IGNO will not listen,
Okay, sir.
because this is the distance mode education. So it is the role of the student is the uh, basic, or the uh, it is the role of the student is the must, then IGNO. Okay. So
Okay.
you have to check your email once in a week regularly. Do not miss.
Right.
If you fix that in Sunday, I will check my email. So every Sunday you should check your mail.
Okay.
Okay.
Sir,
Okay.
can we get this presentations that that you used to share?
Okay. Okay. After all the classes over, I will send these things to RC Bhubaneswar, and they will send these things to you by mail. Okay.
Okay, sir.
Okay. Anyone?
No,
Sir,
sir.
am I audible?
Uh, Abrar Ehad. Say.
Sir, am I audible?
Okay,
Hello.
Mahindra.
Yes, yes, sir. Sir, my question is, this year practical class will be online mode or will be physically for doing the practical class?
Actually, your practical class will be held in your study center, nearest study center. But practical examination will be held at regional centers. So these two things are different. So study center will conduct the practical class, and regional center will conduct the practical examination. Okay. So
And second
so
thing is,
it
sir,
depends that in which location you belongs. So the nearest study center should have a lab facility to conduct the experiment, or your nearest regional center will charge this PGDSC practical class to any of your study centers to conduct the classes. Okay. Anyone, anything? Okay. So if no questions are there, so thank you to all for your patience hearing, and it is a sincere thankfulness from my side and from RC Bhubaneswar for your participation in online class, and hope this participation will continue, and we will have the second class on tomorrow. So thank you to all.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.